Okay, welcome back. So I just want to change this. It's bugging me. Okay, now I'm also going to change the ground, fill of the ground. So just to make it look more like the original runner. So there we go. I can also change the background to match the original. So here we go. This seems good. Now the next thing we kind of want to do is to add collision to our boxes. So here you can see no collision is happening, and we need a way to collide between the player and the enemies so that when we collide we can then end the game or restart it or remove a player. So collision will be very important. Now I'm going to pull up a page here. This page basically shows how to determine collision between two rectangles, because remember that our player is a rectangle and the enemy is a rectangle. So let's see here. If we look at the code, we need a top right and we also need a bottom left. So to implement this, we're gonna have to create the functions, or the functions, the variables. So let's do a top right, and we'll do, it's a new p vector. And the reason I'm making it a p vector is because I want to be able to use it as a point, because I'm just going to draw here. Say we've got a square. In processing 0, 0, or your xy of a rectangle is here. So we want this one, the top right, and then we also want this one, the bottom left. So to do this, we're going to have to use update. So this is going to be a p vector called top right, and then we'll also have bottom left. So bottom left will then also be a new p vector, and then because the player and the enemies are going to be moving, so we're going to do the same for the enemy. It'll also have a top right and a bottom left. Okay, so firstly we need to actually see this point. So we're going to do a stroke, and we'll do it white. Give it a stroke weight of 6, and then we're doing a point, and this point will be top right dot x and top right dot y. Okay, so we'll do the same for bottom left, but first we're going to have to update the points, because they're going to be moving along with the player and also the enemy. So top right will be the x should be this x plus the width, and then the y, so we'll just copy this, and its y will then be this y. So we're just going to run this to see if we actually do get the point. There you can see that's top right. So now we're going to do bottom left. So same principle, bottom left. It's going to have X and Y. And its X will be the same as our X. Its Y will be Y plus the height. So let's run this. So now we've got the 2 points, and this is how we're going to do collisions. So we'll do the same for the enemy. We're going to have it update the points, and then we'll also show the points. To run this, you can see both now have these points. Great. So let's do a boolean called collision, which is going to detect a collision between and then will always return something. So let's say return false. So now the collision will be here and then true. So let's get, we need to get a closest enemy, so that the player know who it's colliding with. So firstly, we'll define a float and set it to infinity, and then we'll also get an enemy and call it closest enemy. So we'll do a for loop to loop through our enemies and then determine which one is the closest. So we'll get the size, and of course I is equal to 0, I is smaller than size, and then we'll create a float, call it d, which will get the distance between our x and our y, and then the enemies dot get I dot x and the enemies get I dot y, and then if d is smaller than this distance of infinity and our enemies dot see here, we also want to only look for the closest enemy in front of us, so we'll get the enemy's x to be, no, the enemies, let's do the enemy's top right, top right dot x to be greater than our x. So this way we'll only ever check for an enemy if it's in front of the player, and then if that is the case, we'll get the closest distance, set it to d, we'll get the enemy, and the enemy will be set to that enemy. Now let's see, variable may be null. Okay, so here we'll say to check for a null. So to satisfy this, if this loop that is looking for an enemy, if it doesn't return an enemy, so then it'll just return false if it doesn't find an enemy. But if an enemy has been found, now we're going to do our checks. So if we go back to the code, we'll see if the top right, and we'll get Y, bottom left Y, and I'm just going to zoom in here. So the top right Y, and then obviously this will be our enemy, bottom left, and you can go through this code. I'll put a link in the description if I remember. Whoops. And then you can check this out. So this is basically what I implemented here. Pause the video, copy this code, get it, and so now I'm going to make another boolean just to check. So let's call this one has collided to see if the player actually does collide. So this is a boolean as well, so we'll add it up top. And okay, so now we're going to have our collision check. So we'll get the player and we'll get our function, which was collision, and then we'll wrap this. So if this is true, we don't need to pass in an enemy because the enemies are global, so we're also checking there. So if that's true, the player dot has collided, whoops, has collided, come on, player dot has collided is true, and then else, this is for all other cases, that will be false. So now just to see that it's working, we can do this. We can say if we haven't collided, let's just grab the variable. If you haven't collided, will just be a normal color, or the normal red. Else we can just assign, let's be explicit and say if it has collided, then we'll just to display be another color. So this should be good. There you can see if the color changes, it's colliding, which is good. So now we've got collision, and we also don't need to display the points anymore. So I'll just comment this out. So let's see here. Okay. Yeah, this seems good. So I think what we should do now is just to get some variety in, is say that an enemy can have a random width of 50 and 75, and the height, because we know we can clear a height of 150, we can say, okay, you can be a random height between 75 and 150. So boing, we're jumping, and this seems to be working. Okay, in the next video, I think we'll start looking at the actual neat implementation, the neural network and the genetic algorithm. There is one more thing I want to do, which is I'm going to have a global speed for the enemies, so that we can just assign it here, and then speed will be that speed. Okay, so we don't have a score. Yeah. Okay, so next is going to be neat, and we'll start by implementing the neuroevolution and also genetic algorithm. Okay.